Hey there, and welcome. Have you ever really stopped to think about what's happening when an ice cube melts in your drink compared to when you toast a piece of bread? I mean, they're both changes, right? But they are completely different worlds. Today, we're going to dig into the two fundamental types of changes that shape literally everything around us, physical and chemical. Let's get right into it.
Okay, let's start with a really simple puzzle. Imagine you've got a piece of paper. You can rip it up into 100 little pieces, but at the end of the day, every single one of those pieces is, well, it's still paper. But now take another piece and set it on fire. What do you get? Ash, smoke, heat. It is absolutely not paper anymore. So what's going on here? What is the core difference between these two actions? That's the big question we're going to tackle today.
All right, first up, let's talk about physical changes. These are kind of like a makeover for matter. It's all about changing the appearance, not the actual substance itself.
So, the textbook definition is a change where only the physical properties get tweaked. We're talking about things like shape, size, or state of matter. Solid, liquid, gas. The key thing to remember is that the deep-down identity of the stuff stays exactly the same. It's kind of like getting a haircut. You might look different, but you're still you. That torn paper? It's just paper in a different shape.
You see these changes everywhere. When you're chopping up vegetables for a salad, you're just changing their size and shape. A piece of carrot is still a carrot. Or how about dissolving sugar in water? The little crystals seem to vanish, but they're still in there. You can taste it, right? Ice melting is the classic example. Just water going from solid to liquid. A glowing light bulb is a cool one too. That little filament gets incredibly hot and glows, but it doesn't actually become something new. And even kneading dough. You're just mixing flour, water, and other stuff together. It hasn't chemically transformed, at least not yet.
Now, here's a huge clue for spotting a physical change. Most of the time, you can undo them. They're reversible. You can take that water from the melted ice cube and pop it back in the freezer to make ice again. You can boil the water from your sugar solution and you'll be left with the sugar crystals. This ability to go back and forth is a giant hint that no brand new substance was ever really made.
Okay, so let's flip the coin and talk about the other side, chemical changes. This is where things get really interesting. This is where a substance has a full-on identity crisis and becomes something totally new.
A chemical change, which we also call a chemical reaction, is a complete and total transformation. The very atoms and molecules of a substance get rearranged. The things you start with, the reactants, get used up, and you end up with completely new things, the products. The best analogy? Baking a cake. You mix flour, eggs, and sugar. You put it in the oven. Out comes a cake. You can't unbake it to get your raw eggs back, can you? It's a permanent change. You've made something new.
And just like physical changes, these are all around us. Cooking an egg, for example, that's a chemical change. Burning anything from our piece of paper to a magnesium strip that flares up with this brilliant white light creates totally new things like ash and gas. You know when milk goes sour and turns into curd? That's bacteria causing a chemical reaction. And that flaky reddish-brown stuff you see on old iron? That's rust, a super common chemical change we're about to look at much closer. Heck, even digesting your lunch is one giant, complex series of chemical changes happening inside you right now.
All right, let's do a little deep dive here. Rusting is one of the most common and, believe it or not, one of the most expensive chemical changes on Earth. Understanding it is the perfect way to see why all this really matters.
So when you see this brownish, flaky stuff on a piece of iron that's been left outside, you're actually watching a chemical reaction in slow motion. That iron is literally being destroyed and turned into a completely different substance we call rust. It's not just a coating, the iron itself is changing its fundamental identity.
So what's the recipe for this rust? Well, here's the chemical equation. You need 3 ingredients. First, you need iron, the metal itself. Then you need oxygen, which it pulls from the air. And finally, you need water, or at least some moisture. When all 3 of those get together, they react and form a brand new substance, iron oxide, or rust. This explains perfectly why a car rusts so much faster in a humid place near the ocean. More water in the air speeds up the reaction.
So why should you care? Because rust isn't just ugly. It slowly eats away at iron, making it weak and brittle. And that has massive consequences in the real world. Think about our bridges, our ships, our cars, all the buildings that rely on iron and steel. The cost to repair and replace rusted metal is just enormous. This, of course, leads to a pretty important question. If we know the recipe for rust, can we use that science to stop it from happening in the first place? And the answer is yes, absolutely.
We basically have two main strategies. The first one is super simple. Put up a barrier. If we slap on a coat of paint or cover the iron with oil or grease, we're physically blocking the oxygen and water from ever touching the iron. No contact, no reaction. Simple. The second method is a little more clever. It's called galvanization. This is where we coat the iron with a layer of a different metal, like zinc. The zinc is more reactive, so it essentially sacrifices itself, reacting with the air and water first, and forming a protective layer that shields the iron underneath.
Now, to see another really cool chemical change in action, check out this experiment. We start with this beautiful blue liquid called copper sulfate solution. But look what happens when we stick an iron blade in it for a while. The whole solution turns green. That dramatic color change is a dead giveaway that a chemical reaction has happened and something new has been made.
And here's exactly what's going on. The iron from the blade reacts with the blue copper sulfate. The iron actually kicks the copper out of the solution, forming a new substance called iron sulfate, which just so happens to be green. And the copper that got kicked out, it gets deposited as that brown coating you can see on the blade. So we went from a blue liquid and an iron blade to a green liquid and a copper-coated blade. That's a chemical change, no doubt about it.
Understanding these changes isn't just about spotting them, it's also about learning how to control them. A fantastic example of this is a process called crystallization, which cleverly uses physical changes to create something beautiful and pure.
So crystallization is this awesome technique for purifying things. And it's really important to note, this process itself is a physical change. We're not creating a new substance here, we're just separating a pure substance out of a solution, letting it form these big, perfect crystals while leaving all the gunk and impurities behind.
And you can actually do this yourself. Here's how you would make crystals of that same copper sulfate we just talked about. First, you heat up some water with a little acid. Then, you start stirring in the copper sulfate powder, and you keep adding it until the water just can't dissolve any more of it. We call that a saturated solution. Next, you filter the hot liquid to get rid of any little bits of dirt. And now for the magic part, you just let it cool down, very slowly and very gently. As it cools, the pure copper sulfate starts to come out of the water, forming these amazing, solid blue crystals.
Okay, wow, we've covered a ton of ground. We've seen things just get a little makeover, and we've seen other things go through a complete identity change. So let's bring it all home and solve our puzzle from the beginning. This little table sums it all up perfectly. Physical change. Do you get a new substance? Nope. Can you usually reverse it? Yep. Think melting ice. Now, chemical change. Do you get a new substance? Yes, for sure. Can you reverse it? Almost never. You can't unburn a log. And that brings us right back to our paper. Tearing it was a physical change. It was always still paper. But burning it? That was a chemical change. It became ash and gas. Puzzle solved.
So now you're equipped to see the world in a whole new way. The universe is constantly changing all around you. Some of those changes are just temporary makeovers, but others are permanent, brand new creations. So as you go about your day, whether you're boiling water for tea or watching a sunset, ask yourself, what changes are happening right in front of me? Are they just a new look, or are they a whole new identity? Thanks for joining me.